Today's lesson is on slopes of parallel and perpendicular lines. Parallel lines have the exact same slope, so that makes them fairly easy to identify. For instance, if we want to look at this group of equations and identify which lines are parallel, both of the first two lines have slopes of 5/3 because they're both in y equals mx plus b or slope-intercept form, so we can tell that the slopes are both 5/3. So we can say these are parallel because both slopes are 5/3. Now, the next two, those are also in slope-intercept form, even though there doesn't appear to be a b here, it is 0. And the number in front of the x's are 1 in both cases. So these have the same slope, so these are also parallel. And we'll say that both slopes are 1. So let's move on. Let's look at these equations here. Let's see if we can identify the slopes. In the first one, again, that's in y equals mx plus b form, so the slope is 2. The second one's also in slope-intercept form, and the slope is -2/3. This next one is not, so we may have to play around with this a little bit. 2x plus 3y equals 8. So what we want to do is get this into slope-intercept form, so we're going to have to solve for y. So subtract 2x from each side, and we have 3y equals -2x plus 8. Divide everything by 3, and we get y equals -2/3 x plus 8/3. And so the slope of that line is also -2/3. So we know that these two in the middle are parallel. And this is actually supposed to be a minus sign right here. Make it into a big minus. So we have y minus 1 equals 3 times x minus 3. Well, notice this is point slope form. Y minus y1 equals m times x minus x1. So our slope is really apparent as to what it is because in this case m is 3. Alright, so now we pick out which lines have the same slope, and it's only the middle two lines. So these two lines in the middle are parallel. Okay, and those are the only lines in that group that are parallel. Now, perpendicular lines have slopes that are the negative reciprocals of each other. So let's just remind ourselves what negative reciprocals are. We know what reciprocals are from dividing fractions. So let's just think about that. If you have the if you have the fraction 2/3 and you want the negative reciprocal, you are going to turn the fraction upside down and change the sign. So we get -3/2. If you have something like 5, well, put a 1 underneath it. Turn it upside down, put a negative in front of it. If you have -3, put a 1 underneath it. Turn it upside down, but change the sign. If it is negative, make it into a positive. So if you have -5/7, you are going to make that a positive 7/5. So that's what we mean by negative reciprocals. Now, perpendicular lines have slopes that are negative reciprocals of each other. So we want to see which lines are perpendicular. Now, one thing to keep in mind, if you have a line that is just something to the effect of y equals 3 or x equals -2, y equals 3 is just a horizontal line. Remember, y equal to a number is a horizontal line. X equal to a number is a vertical line. Okay? Well, a horizontal line and a vertical line are going to automatically be perpendicular to each other. We don't even need to think about the slopes or the negative reciprocals or anything like that. Well, let's look at the next pair of lines. What's the slope of this line? Y equals 3x. Well, the slope is 3. How about this next one? Let's distribute. See if we can get it into y equals mx plus b form. So we have y equals negative 1/3 x plus 4/3. Well, the slope of this line would be negative 1/3. Are 3 and negative 1/3 negative reciprocals of each other? They sure are. So these last two lines are also perpendicular. Let's move on to the next page. We want to write an equation in slope-intercept form for the line that passes through 410 and is parallel to the line described by y equals 3x plus 8. So let's think about it. What's the slope of this particular line here? The slope is 3. What's the slope of the line parallel to it? It'd be the same thing. The slope would still be 3. So you're given the slope of 3 and the point 410 that it passes through. Well, there's your x1, y1, and you have enough information now to use your point slope formula. So let's plug our numbers in. So we have y minus 10 equals 3 times x minus 4. So I have y minus 10 equals 3x minus 12. Add 10 to each side. We have y equals 3x minus 2, and that's in slope-intercept form. And so there's the equation of the line that's parallel to y equals 3x plus 8 and goes through the point 4, 10. Now let's take a look at this one. Write an equation in slope-intercept form for the line that passes through the point 2, -1 and is perpendicular to the line described by y equals 2x minus 5. All right, so first of all, the slope of this line is 2. Now we need to find the slope of the line that would be perpendicular to that. Well, that would mean we'd take the negative reciprocal of 2, put the 2 over a 1. Now we're going to turn it upside down so we get 1/2 and change the sign. So the slope we're working with now is m equals negative 1/2. That's the slope of our new line. Now we know a point that's on that line. It's 2, -1. So there's our x1 and our y1. And now we're going to use our point slope formula, y minus y1 equals m times x minus x1. So I have y minus -1 equals negative 1/2 times x minus 2. Two negatives become a positive, so we get y plus 1. Use the distributive property, so we have negative 1/2 x. Negative 1/2 times negative 2 is positive 1. We want to get y alone, so we're going to subtract 1 from each side. Hey, the ones all cancel out. So we end up with y equals negative 1/2 x, and that is the line that's perpendicular to the equation y equals 2x minus 5 and passes through the point 2, -1. I'll see you in class.